Welcome back to VR and Godot. Apologize for the large time gap between videos, but I thought I'd get this started back up because I saw Humble Bundle had a VR uh, pack that I bought the other day and was having some fun getting my VR back out, so I thought I'd make this update video. So anyways, this is the status so far of my VR Weeping Angels or Maze game, and I thought I'd show it off. So we've got walls that are reusable. We've got this nice tile floor. I just downloaded these textures from the internet, and they're open source or free to use images. And then I've got these models I made myself, and I kind of added a bevel to the edge of these, you can see, and that's so that they're easy to place together. Anyways, and then I've got this, which is kind of the let me stand up and you can see inside of it. This is the fountain that was going to be the goal, and it's got a little bit of water coming out. I did model that whole thing, and I was having quite a bit of fun with that, but I was very happy with the way it turned out. It looks pretty good in VR. Anyways, there are no monsters and stuff yet. That's kind of the next task, but I do have, as far as features go, it's got this flashlight, which you can kind of see the shadow of it there. I probably put a little bit more work into it than was necessary since it's so dark, but yeah, it is controlled by your controller, so wherever I point and hold the controller is where the flashlight goes, and it feels pretty good. And then the spotlight effect is really nice. I was pretty happy with that, and I made a nice dark sky that's got a little bit of light to it, so it's not totally pitch black, which gives it a little bit of texture. So anyways, yeah, you just kind of walk around this maze, and it does have collisions, so I can't walk into a wall, but or I should say I do walk into walls, or you can't walk through them. But it does have a bug that is, it takes the center where my center of my play area there, and that's kind of where the collision shape is. So it does have some weird angles because it's not going off my headset; it's going off that center of my play area, and my as you can see, I'm not standing in the center of my play area of my room, and so like right now, I'm actually running into the wall, even though I'm a good 2 feet away from it. So, anyways. Yeah, this is the progress so far. So let's jump out of the headset and we'll take a look at the code. I know that was a partial screen for you guys, but for me it was all encompassing. Apologize.
I'm here too.
Yeah, my daughter's here too. Apologize for the coughing. I just getting over cold and stuff and still recovering. Alright, so this is the scene, and one thing I did that was helpful for this dark scene, I'd never done a dark scene before. So what I did is I created this world environment, and this is where you define things like the environment here. And so you can see things like the background, and here's where I set the sky, and I set the ambient light to this black, and I lowered it down and stuff, and I set the fog is off. I played around with fog, but it didn't have the effect that I wanted it to. Anyways, so what I did is I set this one to be bright, and I think that's why this energy is at 1. And then I made a second one here called the dark environment. And if we take a look at this one, we notice it's got, the sky stuff, and then ambient light. Yeah, so these are 0 for the ambient light, whereas the one here associated with my scene has got the energy as 1. So what that does is it allows me to develop here in this bright scene, and then when the game starts, so here in the startup script, not here. Here we go. So I put the script right here on the world environment. So when it does, it sets that environment to this resource. So that makes the game dark as soon as you start it up. So that was super helpful because that way I can develop here in the in the light, and then when I actually get into it, it's nice and dark. So I really apologize for the voice. These are just little prefabs I made, and I just placed them in here. The ground, sorry for the zooming, the ground is just a plane, I believe. So, yep, here's the floor. I did a CSG box, I guess. So it probably, yep, has a little bit of depth to it. And these are neat in Godot because previously I don't think we had the capability of creating like a 3D object per se. You had collision shapes and polygons, and of course you have meshes. Don't know where they're at. They are in here somewhere. But you didn't have an object that was visual. Okay, here's the visual stuff. Yeah, geometry instance. So you had a mesh instance, and I think these were in there before. And this is how you do a mesh that you pull in from, say, Blender or something. But I don't think there was any like boxes and spheres and stuff that I can remember. I guess we could search here. Yeah, so these new CSG spheres and boxes and stuff, these are all new. And I think this was in Godot 3, I believe, or 3.1 they were added. And so these are really nice for prototyping out your game. But in our game, it was particularly useful for just making this floor without having to go out and create an asset just for that. So anyways, that's how that was done. I probably could have done these walls that way too, but I did like putting this, well, two of the nice things is you can control the UV of the textures, and the UV just stands for, so you have X and Y, but the U and V is the width and height of where the texture goes. So if you change the U on this, it would make this texture rotate around that way. So that's what the UV stands for. Anyways, that's very simple terms. I added a bevel to these, and it made it a lot easier to stick these together, because you can see that's not perfect, but it looks pretty good in the game with that bevel. Now you could make these a little bit more perfect by using the grid feature up here. I think that's it. Yeah, the snap mode, and you can also turn on the view grid, which I do have it on. That's what this white stuff is, and you can get it to snap to those. But then you have to make your objects very precise to those dimensions, which I did not. So the grid was not working out so hot for me with my default stuff. So here's my player character, and you can see I don't have any other monsters or anything. My plan is to add, like 2 or 3 monsters, one over here, and we'll see how that goes when I get there. What really delayed me was I got demotivated on trying to model up a monster, but I just noticed that in the latest Humble Bundle they had a low poly game asset pack. Let's see if I can find it. Here we go. This has got like 9 days left on it, so you may be able to catch it in time. Anyways, it's got lots of little characters and stuff, so I figure I can probably pull something out of this to use for my monster and get through the rest of this. So we'll see about that. But anyways, yeah. So let's take a look from a technical standpoint what we've got here. So that's kind of a tour of the design of the game. So let's look at the player. And this is where the most of the work was done. So let's go ahead and open this. So here's our flashlight, and what it's got is it's got a light inside. So this is my mesh. This is what I designed out in Blender, and it's got 2 pieces. It's got the body of this, and then it's got this little piece of glass here. And I set a real bright white thing there. And then inside it, it's got a spotlight, so you can't see it completely. Let's turn off the flashlight. So there's my spotlight, and it's just sitting inside of the flashlight, and then it shines out. And so that's the that's how the flashlight works. And so then I just took this little object and put it inside of the hand. And remember, before we had the controller there, the visual controller that you could see, but I just deleted that and then added this flashlight there in its place. Now, of course, you could add a hand model and put that around the flashlight, or you could have the hand and then pick up the flashlight, and that would just make this flashlight a child of the hand, and that's how you would do that. So anyways, this makes it to where you just have the flashlight in your hand. I might have put a button on it so you could turn it off and on, but I don't think I did. Yeah, so this script is all about moving around. So we'll look at that. But yeah, that's how the flashlight works. Now this is just on one hand, and you can see here's my headset right here, and then off to the right is my right hand, and so that's where the flashlight's at. Don't do anything with the left hand, and we could, but I didn't think it was necessary for this game. So let's go ahead and look at the movement. I think up here on the HUD, this is boilerplate from what I showed before that came with setting up the VR. Yeah, that's the same script. Yeah, this is again the same thing. This just initializes the VR and sets up the settings appropriately and gives messages if you don't have it. And this again only works for Oculus, but you could configure it for more, or a different headset if you had a different one. And then yeah, so here's the player. So this is all the movement stuff. So I think this is probably a good place to start. So here I'm making references to that left and right hand and the headset. That way I have easy access to them. Although I probably only use the right hand, if that. And then there's a boolean for whether or not the direction is pressed, and I think I use that for the snap turn. So this is in the process, so every frame it's going to do this. And I believe I clipped this from one of the examples and then modified it a little bit, one of the Godot examples that's out there. And so we'll just walk through it real quick. It's been a long time since I looked at this, so I'm going to be pretty rusty on it. But what it's doing here is it's getting a vector for the direction that you're pushing the stick on the joystick. And I use this for turning and for moving forward. So the dead zone is on a joystick. If you just leave it without touching it, they tend to have what's called a dead zone, and your joystick will actually not be at 0, 0 when you're not touching it. It actually kind of fluctuates a little bit around 0, and so you need this dead zone so that your character doesn't like twitch around and stuff, or even drift when you're not touching the joystick. So here it's just looking for a controller dead zone, so it's making sure it's larger than that, whatever that dead zone is set to. It looks like it's 0.1. And joysticks, I think, usually go between 0 and 1, so 0 being you're not touching it at all, and 1 being it's, pressed all the way to one side. And then we've got a forward direction and a right direction, so here it's just peeling out the pieces of that transform of the joystick. Actually, this is pulling it off in the headset. The reason I did this is because I like it when you're in the VR and you press forward on the joystick and it goes the direction that you're facing, and not necessarily another common one is to go the direction of the joystick. That way you can point in you can be looking in one direction and pointing your joystick in another direction and run, a different direction than you're facing. But I like it when you move forward. It's also a little bit more comfortable, I find. I find I get less sick if I do that. So then we create a movement vector based off from the joystick. So that's the direction the joystick is being pressed. And then we combine those with delta, which is our process delta up here. Combine it with our movement speed, so this is how you would adjust how fast you turn and move. And then with our headset, along with the movement vector from the joystick, all those get combined together, and that comes up with our movement. So that's how we're going to move the character. And then we pump that through this move and slide function. That way we get our nice collisions from the character object. So let's go back, and if I look here at my player, I've actually got this collision shape right here, and so that's going to be my, zooming out, I've got this nice ellipsis. That's going to be my collision shape so that I run into walls and stuff. And if you wanted to be able to get closer, you could shrink it down this way. I probably shouldn't have fooled with that. And then if you want it to be taller and shorter, you could adjust it here. Okay, and then let's get back into that script. So that's our move and slide, and then this sets the up direction. When we do 2D games, we only need to define the X and Y, but here it's X, Y, and Z. So that's why Y is up. It's set there. Let's see. Right hand button press. So here I'm just recording what button was pressed to the log. So if I play this, and I don't have my headset on, but if I push a button on my joystick, it's not doing anything. Okay, I must have something disconnected there, but that was probably what I was playing with, was figuring out how to turn that on and off. Here is the, here, this is good. So this is the rotate. So this allows me to rotate left and right. And I believe these are callback functions. So don't set I don't know how these are set up, but I bet we call them from down here. So let's take a look down here on the right hand. So remember that on right hand turn pressed. So we're going to go onto the right hand, and then here, there's let's see. I bet it's set up in the nodes over here. So right hand signals. Yeah, here it is. So on turn pressed, I'm going to call this on right hand turn pressed. So that's where the connection was. And that is set up right here. Turn pressed. So I've got these signals here that I'm going to call from down in here, and then I've attached them using the signals right there. So that's how that works. Apologize if that's a little confusing, but so the way this works is we've got a turn cooldown. So the reason for that is I didn't want you, when you're in VR, if you touch to the side, I didn't want it to just spin like crazy. Also, if you didn't use this, you could use a smooth spin, but I find that's pretty discomforting compared to a snap spin, and so I like the snap spin, and that's why we have this, is it's on cooldown. We have a cooldown there. So what we do here is we make sure that it's activated, or that it's active. So if they have their controllers turned off, I think this does not work, and so you want to, we don't want to show it if the controller's not on. So that's what that's about. And then here, and I think that was just a carry forward from the example. So here, we're checking to see if that cooldown is on. If it's not, then we make sure the axis is more than 75%. So if they've just touched it, especially since we use the same controller stick for forward and side to side, if you press forward, you're likely to be pressing a little bit to the side. And so we want to make sure that if it's less than most of the way over, that we're just kind of ignoring it. So that's what this is about. We're making sure it's either greater or less than 75% to the left or right. But if it is, then we emit that turn signal, and then we turn the cooldown on, and then we start a timer that will turn it back off. So if we come down here, here's where our timer timeout. We're going to turn that cooldown back off and emit the signal that it's done cooling down. So if we look at our timer here, and we look at the time, it's 0.4 seconds. So you can't turn faster than 0.4 seconds between touches. So that's still pretty fast, but it's enough that if you just hold it down, it won't just keep spinning you uncontrollably. Alright, so coming back to this, set to visible, I guess, and then Yeah, this is just saying that the controller's active and turning the visibility on. I think this is all from the boilerplate stuff that was there before. Anyways, so that's all there is to it. I don't think there's any code anywhere else so far. There'll be a little bit around the monsters, and then there'll be a little bit around the goal of the game. So when you reach the goal to do something. Oh, I guess that's something else we could look at real quick. Just looking at this thing. So this was the fountain. This is a little prefab I made. I was pretty happy with how it turned out, how the water effect turned out and whatnot. All it is the bowl and stuff that I modeled. So it's got a water, which is just a circular plane right there. It's got the water spouts, which are just those little cylinders there. It's got the bowl up here and the base down here, which are two separate pieces. And that's it as far as modeling. And then the particle systems that come out of each one, I made one, got it working, and then I just cloned it to the other ones and then moved it into position. And all this is, if we look over here, it's always emitting. It's got 50 particles, so it's got quite a few particles. And we can bump that up, you can go up to, say, 100. It gives you a little bit more solid feel. But if you go too low, like that, it looks a little bit squirty. So 50, I guess, was the lowest number that felt good to me. Anyways, let's see. Most of this is pretty standard, but if we come into our process material here, this is how you define it. So the initial velocity, that's how far it's squirting out. So if we raise that, see how they squirt further. If we lower it, they squirt less. There we go. And then not sure what all. So here's the spread. So that makes it squirt straight out. That makes it squirt out, wider. So if anything, it might look a little better, a little tighter than I had it actually. That looks a little bit better, honestly. And then as far as the emission, oh, that's the emission shape. I don't remember where you set the, might be here in the drawing. Ah, the geometry here. I'm looking for, oh, here we go, draw passes. So this is where we define the material. So that material, I just add a little bit of transparency to it here. So if you look at flags, it should have transparent set on. And then the albedo has the alpha here about 50%. So if I made it more like that, it'd be solid color. And like that, it's totally transparent. So, somewhere in the middle kind of gives it a nice effect. Yep. So that's the thing. I don't remember where we set the shape. But obviously it's just a sphere. I would think that would be in geometry. But anywho, might be this one. Ah, here we go. Yep, this is where you define that. So I just assigned it as a sphere mesh and then added that material there. So yeah, this is where you set up the shape. So I could change that to a cube mesh. Ooh. And obviously that's spitting out cubes. I'm gonna undo that. But that's how you would spit out a different shape if you wanted to. And another common one is to spit out I think quad meshes. And I'm not sure, I guess they are. I think there's a way you can make them always face the player, and that way you get kind of a billboard effect. But yeah, this worked good for the water. Anyways, just wanted to show how that worked because I thought it was pretty interesting. And that's how a lot of this stuff works, is you take these simple building blocks and you combine them together and you put it into an object like this, and then all you have to do to add it to your game is just drag it in. So here, I've got a fountain there. If I wanted another fountain, I just come over to my fountain, drag it in. Now I've got another fountain, and obviously it's a lot bigger than the other one. So what I probably had done is scaled it down. So I got the scaling, and I shrunk them down this way, and shrunk them down that way, shrunk them down that way. Now I've got another funny looking fountain. So anyways, that's how this 3D development works. It's very similar to the 2D, and the VR just adds another fun little element to it. Well, I think this video is long enough, and I hope that I covered stuff well enough that it was helpful, and hopefully very soon I'll get to start messing with the AI. They're not going to be very intelligent. They're basically just going to be, say, a little guy standing here, and he's going to try and shoot a ray at the player, so that'll be something interesting we get to try out. If it hits any walls, then he's just going to stay dormant. But if he sees the player, then he's going to start walking towards the player. And then of course I need to do the reverse, which is if the player's looking at him, then he freezes. But if the player's not looking at him, then he'll proceed towards walking towards the player. And hopefully I can have some sort of visual indicator on him so that you know that they're coming towards you. And of course if you're not looking at him, I don't know how you'll see that, so maybe instead of being a visual indicator when he's moving, it should be based on how close he is to you. So we'll figure that out, and then we'll have a goal here, so when you get to the fountain and touch it or something, then we'll say that that's the end of the game. So alright, see you next time. Thanks for watching. Bye.